Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss a question. The question is diagonal order of a binary tree. So what this question is asking, let's discuss that. But before that, let's discuss one property of a binary tree or a binary search tree. Both the trees follow the same property. So if a binary tree is given like this, 10, 20 and 30, then if instead of writing some values, if I just take nodes, if I take a node here, then the left child of the node will be at minus 45 degrees distance, and the right child of the node will be at the positive 45 degree distance from the mid of this root node. Okay, this is one thing, but how this property is useful to us, let's discuss this. If it is a binary tree, then the same property should apply to this and this node, which means the the right child of this node is at the 45 degree distance and left child is at the 45 degree minus 45 degree distance, right? So when this node is formed, this node and this node are coming in the same line. So this property is also useful while solving the question width of shadow of the binary tree. This property tells us that this node is if I light a bulb from here, then the rays or then the shadow that is going to be formed are going to overlap for this node. The shadow is going to overlap. Similarly, if I make this node, this is also going to be in the same way, in the same path of this root node. So this is a property of a binary tree. Now let's discuss how this property is going to be useful to us. I'll make a binary tree 10, 20, 30. Now when I make 40 and let's say 50 here, then these two are going to overlap, or instead of saying overlap, I can just write here it as 50. Okay, similarly here let's say 60, 70, 80 is going to be under this 20. Okay, and similarly if I draw, instead of writing this, 80 is going to be under this tree, and next if there is a right child present of 80, let's say 90, then it is going to be under this 10, 50, 40 and 90, or you can say that the path, if I draw a path from here, then these four nodes are going to come in the same path. Okay, now let me write some more values here, let's say 100. Okay, now if I now in this question, what the question is asking us, the question is asking us to give us or the tell us all the diagonals possible in a clockwise direction. Then what are the diagonals possible? We can see that this is one diagonal that is possible. Okay, similarly this is also a diagonal that can be that is possible, but before that, let's see, if I draw a line like this, then these all these values are coming in the same line. That means this is also a diagonal where the components, where a diagonal which is having different components in different part of trees. Okay, here the diagonal that was forming was having, sorry, here the diagonal that was forming from this 10 as a head node was having all the components connected, or all the elements connected to each other. That is, 10 was connected to 20, 20 was connected to 60, and 60 was connected to 100. But here, if I draw a line like this, I am getting a diagonal 30, 50, 40 and 60, 80. But in this diagonal, 30 is connected to 50 and 40 is connected to no one. If in with respect to this diagonal, 40 is connected to no one and it is also not connected to anyone. So here I can say that I am getting a diagonal. The diagonal is a valid diagonal, but in this there are multiple components. These components are present in the different part of the tree. Similarly, if I draw a line, I am getting 70 and 90 in a same diagonal. 70 and 90 in a same diagonal, but they are not connected. Okay, now to do this, we can also see that if I say that this is in one level, this is in the second level, and these four are in same level. Okay, how this level is going to help us? In the previous series, we have discussed that if we have a binary tree like this, 40, 50, 60, 70. For now, let's take this much only. We know that this is coming in the same level. These two values are coming in the same level. These four values are coming in the same level. So how this level is going to help us? These levels are going to help us to determine that if I am taking 30 as my head node, then what are the all values or what are the all components that are going to lie in the diagonal, in the current diagonal. So if I say that if I take 30 as my head node, then obviously 60 is going to be in my diagonal, and 50 is also going to be in my diagonal. Why 50 is going to be in my diagonal? Because the first property that we have discussed, that 60 and 50 are going to lie in the same direction. That is, if 50 is here, then instead of drawing here, I can write 50 as this also, 50. So we can see that 30 and 60 are coming in the same direction, and 50 is also coming to this in the same direction. So we can see that we are actually traversing in a level order kind of thing. Okay, so let's try to discuss the approach, that how we are going to approach this question, or how we are going to solve. And while discussing the approach, I hope that you'll get a clear idea that what actually we are going to do. If this is a binary tree, 10, 20, 30, 40, 50, 60, 70, let's say 80, 90. Here you can see that 50 and 90 are coming in the same direction, same diagonal. If I draw a diagonal like this, 50 and 90 are coming in the same diagonal. Similarly, 30 and 60 are coming in the same diagonal, and 60 and 50 are coming in the same path of 10. Therefore, these two are going to be in a same diagonal. This property we have already discussed in this video only. And if I take, let's say, 100 here, and let's say 110 here. Okay, now we can also see that 100 and 110, these two are going to come in the same diagonal. Why in the same diagonal? Because if I draw this here, 110, then we can see that if I draw a diagonal like this, I'm going to get these two in the same diagonal only. We will discuss why it is going to be in the same diagonal, but for now, let's write it. Let's say 110. Okay. Now, to do this, what we are going to use? We are going to use a different data structure, that is queue. We are going to create a queue, and in that queue, what we are going to do? First, we are going to add this 10. Okay. After adding this 10, we are going to make some array list. That is, this array list will represent the diagonals. Okay, this array list is going to represent the diagonal. This means that what are my valid diagonals? My valid diagonals should be, let's write them here, 10, 20, 40, 80, right? Next valid diagonal is nothing but 30, 60, 50 and 90, right? 30, 60, 50, 90. Next valid diagonal is 70 and 110, and next valid diagonal is 100. With this, we are able to recognize that I was saying I gave a wrong statement, that if we draw a diagonal like this, we are getting 100 and 110 in the same line, but instead we are going to get 70 and 110 in a same line, and 100 is going to be a separate diagonal with element with only one element. Okay, so these are the some answers. For now we have written these answers. Now let's try to see if we are right with these answers or not. We'll later on check these. We will later on check these values. For now, let's focus on solving the question. That what will be the approach. First, we have inserted 10 in the queue. Now size of the queue is 1. This queue tells me that the number of components, if there are different components, as we go on solving, you'll get you'll be able to understand it more clearer, that this queue is nothing but it is going to hold the different components if present in the same diagonal. That means it is going to say that, okay, I'll just start solving and then I'll discuss when the point when we are at the point 30. I'll try to explain it more clearer to you. So first, initially size is 1. Okay, we are going to perform some operations. That is, first we are going to remove this, and let's say this is small answer and this is first diagonal. In the first diagonal we are going to add this 10 is added. Okay, now we asked 10 that before leaving this 10, we asked 10 if you have any right child. If yes, if this 10 says that I have a right child, then do what? Then add that right child in the queue. And if you have any left child, add it in the answer, that is in the small answer, that is in the this array. Okay, these two things we are going to ask to every node, that if it has a small child, a left child or a right child. And if it has a right child, what operation we are going to do? We are going to add its right child to the queue. And if it is going to have any left child, we are going to add its left child to the answer. Okay, now let's move to this point, that is 20. That is 20 here. In the array we are going to we are going to give choices to the values present in the array. So now we ask 20 if you have any right child. It says yes, certainly I have a right child. Then we add its right child to the queue. We ask that if you have a left child. If yes, then add it in the answer array list. Okay, now with this we go to 40. We give choice to, or we ask to 40 if you have any right child. It says yes, I do have a right child. Then add it in the queue. Okay, now if you have any left child, add it here. Okay, now to 80 we give choices, and we ask 80, do you have any right child? It says no, I don't have any right child. So no problem. Okay, no, you have no right child. Then we ask him that if it has any left child. It says that I don't have a left child. So when we reach to a point where there is no left child and no right child, this means that diagonal is fully traveled. Okay, this tells us that this diagonal is fully traveled. When this diagonal is fully traveled, when size is also becoming 0, that is number of components we had to perform operations on. Initially the number of components, how many number of components were there? 1. We performed operations on how many components? 1 component. Let me tell you how many components are actually there. There is 1 component, there is second component, third component, fourth component. Similarly, there is going to be this and this as a single component. But let's not discuss those components here. Let's see that why these 4 are actually components. These 4 are actually components because these are the starting values of the diagonal. So that's why we are considering them as components. So I'll tell you initially only that these values will definitely come in our queue. That is, there will be a certain point when we are going to add these values in the queue. Okay, so for now let's move on. When the size is going to become 0, when the size of the queue is going to become 0, it means that the total components that were present for this diagonal have been used. And also when there is no value at the left child to add in the answer, the diagonal is fully traveled. Now this null and this 0 tells us that this null actually tells us that to move on the next component, and this 0 tells us that move on the next diagonal. Okay, null tells us to move on next component, next component component, and this size is equals to 0 tells us what, to move on next diagonal. Okay, these two are important things. This null tells us that all the components, or let's say all the values that can be considered in this diagonal using or we can say that all the values that are attached to each other in this diagonal have been traveled. Now there might be possibility that there are some values that are included in this diagonal but are not attached to us and might be present in the whole binary tree at some other point, should be traveled now. So I hope that what I'm trying to say is clear to you all. Now let's move to the next diagonal. Obviously size became 0 and we got the null value here. We are going to move to the next diagonal. So in the next diagonal, here now size have become 0, but this size 0 tells us that this component is over. Now the size is going to update because work for this 10 is done. Now this work for 30 is going to start. So what is the size of this queue now? This queue size is 3. What this 3 tells us that? This 3 tells us that there are total 3 components. Diagonal is going to be 1. There is going to be 1 diagonal. But this diagonal is breaked into 3 components. That means there are total 3 components, and using those 3 components I am going to get my whole diagonal. Okay. So now let's start moving from this 30. From this 30, what I do? I remove it. I add it here. I ask 30, do you have a right child? It will say yes, I do have a right child. Then do what? Add it here. I have added right child to here, 70. Now what will second question we are going to ask it? The second question is going to be, here it will become 2 because we have processed 30. That why the number of components remaining are 2. Now we will ask 30 that do you have left child? It will say yes, I do have a left child. Then add it here. Okay, then add it here. Now we are going to ask 60, do you have a right child? It will say no, I don't have a right child. Do you have a left child? It will say no, I don't have a left child. What this n means? This n means that move to the next component. I don't have any other component or other value through which you can add or you can ask questions to them. I don't have any other values. So the final member of this line or this tree was me. The final member of this family was me. Now go to next family. It is telling us that go to next family. So now work for 30 is done. Now work for 50 is going to be done. When we remove 50, add 50 here. Component number, the number of components that we can process now is remaining 1. Okay. Now we are going to ask 50 that do you have any right child or left child? We are going to ask 50. It will say I don't have any right child or left child. Okay, if you don't have any right child, left child, this means move to the next component. We are going to move to next component, that is 90. This will become 0. We'll add 90. Where is 90? 90 is here. We'll ask him, do you have any right child? It is saying yes, I have a right child. Then do what? Add this right child here in the queue. Do you have any left child? It is saying no, I don't have any left child. Okay, then if you don't have any left child, then this is the only, because the size of the queue became 0. This means that move to the next diagonal. This means this diagonal is completed. Now as I previously said that all these values will certainly come in our queue. We can see that 10 at the start of the operations on these nodes, 10 came in the queue. Now 30 also added, 30 is also added to this queue. 70 is going 70 is also added to this queue. Now we are going to see if 100 is going to be added or not. But we were able to see that there are some other values that are also being added to this queue, that is this 50 and this 90 and this 110. That is 50, 90 and 110. This 50, 90 and 110 tells us that they are part of a diagonal, but not as a head, not as a head member. They are part of a diagonal, but not as a head member, which means that their starting point is at some other point. That is, the starting is lying at this point for 50, the starting is lying at this point, and it is a part of that. So to access this 50, the 50 was added to this queue. This means that this 50 was a component through which there might be, if there was let's say there was 120 here, then this, using this 50 I was able to travel 120, right? So this means that this 50 is a component through which, if possible, and if it has any childs, I am going to go there and I am going to include that in my diagonal. Okay, so I hope I was able to make myself clear here. Now let's move to the third diagonal. While moving to the third diagonal, what are the values that are going to update? These three are done. Size is going to again change. What is going to be the size? The size is going to be 2. Now we are at the 70. 70 is going to be deleted from here and add to the third array list, or third diagonal we can say. Now we ask 70, do you have any right child? It says yes, I do have a right child. Add it here. Do you have any left child? No, I don't have any left child. Then go to next component. Now process to the next component is going to be done, therefore our size is going to be 0. This is going to say, do you have any right child, left child? No. Add it here. Now fourth diagonal. What is this fourth diagonal telling us? This fourth diagonal is only 100, that is size is going to be 1. We are going to process it and it is going to be 0. Therefore 100 is going to be added here. Now this is our final answer. Okay, now let's try to match it with the answer that we have already written. This null is going to be nothing. Let's try to match if the answer is going to come or come same or not. Where is our answer? Okay, here is our answer. So what is the answer that we are getting after doing the dry run is at this point. And what was the answer that we got when we draw the diagonals? That is when we draw some lines like this. What was the answer? The answer was, let's see, 10, 20, 40, 80, 10, 20, 40, 80, 30, 60, 50, 90, 30, 60, 50, 90, 71, 10, 71, 100. So therefore we are getting the correct values. Now in what manner we have to return the answer? These are all in a single array, and there is an array of, let's say, diagonal, that is containing their addresses. So we have to return this array, this diagonal array. So I hope the explanation was clear to you all. What we are actually doing, we are doing nothing, but we are using this property first. The property tells us that this node is going to lie in the same as the root node, and this node is also going to lie in the same node. Therefore this is going to be one diagonal. Okay, this is going to be one diagonal. This is telling us that this level is helping us to determine that if this component, or if there this level is actually helping us that if there is any element in the diagonal that is going to lie on any other point, that is in the same level but at any other point, then I have to include that component also inside that diagonal. So to using this level thing, we are actually traversing through the array. Actually we have did the same thing while doing the level order traversal of the binary tree. We actually moved level by level. Here also we are moving from this level 0 to level 1, then level 2 and level 3, and eventually we are adding the values. Obviously if I am at 30, if I am at level 1, the diagonal elements are going to be below in the below level. right? So therefore, first obviously, now let's try to code this question. What we are going to do? First, we have discussed that we need a queue, so we are going to make a queue that is going to be of type tree node. We'll name this queue as queue only, and this is going to be a new list. Okay. Now second thing, what we added, what we need an array list to add to store our answer. So it is going to be array list of array list, because the answer that the diagonals that we are fetching are going to be in form of array, that is in the form of array list. So what is an array list of array list? It is nothing but this thing only, that is there is an array and it is containing some other array, right? So that's why we are going to use array list of array list. So this is going to be an array list of what type? Integer type, and we are going to name it as answer. Now what was our first step? Our first step was to add the first element in the queue, that is queue dot add last. We are using actually a queue made up of linked list. That's why we are using this function add last, because what is a queue? If I want to design a queue using a linked list, what I am going to do? The property of a queue is that we can add from backward, that is add from last, and we can remove it from first. So therefore we are adding from the last side. So what we are going to add? We are going to add root. Now our work will start, that is while queue dot size is not equal to 0. Till then we have to work. Okay, now we will make another variable size2. This is going to do some works. Using this size, we are going to do work on the components for that current diagonal. That is, if we are at this diagonal, let's say if let's say there was 10, 20, 30 and there was some 40, then this diagonal containing 30 and 40 having two different components, that is one is 30 and second one is 40. So to access them, we are going to use we need a size, or we are going to run a loop till those two are not accessed. So size2 is going to be queue dot size, right? Now second thing, we need a small answer array list, that is array list of integer, that is going to be, let's call it as small. Okay, now next what we are going to do? We are going to run a loop, and till size 2 is greater than 0, we have to run a loop till size 2 is greater than 0. Now next thing, what we have to do? We have to first remove the first node, that is we are going to store that in some, let's say, rem, and we are going to remove that first node, that is first element from the queue, that is the first component, and that first component is nothing but a component that may be head of my diagonal, or might be lying in that diagonal. Okay, so what we will do? Queue dot remo remove first. Okay, now we are going to iterate, or we are going to, what we are going to do now in this case here, let's see, we are going to move from here to here, then here to here, and then here to here. So till what point we have to move? Till, that is while, till what point we have to move? Till this node or till this removed node doesn't become null. Till then we have to move. So while my rem is not equal to null, I have to keep on moving. And obviously if I have to move, I have to move in which direction? In this situation, for this question, we have to move in right direction. So I can say that rem is equals to rem dot right. Okay, now what we have to do, we have to give choices, we have to ask the removed node that, hey removed node, if you have any left component, that is if your left component is not equal to null, that is not equal to null, then do what? Add it to the queue. So queue dot add last what? Rem dot left. Okay, here also rem dot left. Okay, and if you don't have any left value, then we are already going to, we are moving to the next diagonal, that is we are going to move on the next component. But before that we have to add this in we have to add this in our small answer array list, that is small answer dot add what? Rem dot val. Now when these things are done, what we are going to do, we are going to add the small answer, that is add answer dot add this small answer, and then we are going to return the small answer. Let's try to run this code, and there is some error expected in line number 32. Line number 32. Okay, it is saying successful. Let's try to submit this code. So all the test cases are passing. So with this, I hope the question was clear. The basic thing that we had to do was nothing but, first we had to add in queue, that is add the first element, that is the root node in queue. Second thing, remove that and add it to where? Add to answer array list, right? Third thing, what we have to do, we have to ask that removed node that if it has right child, then do what? Then do, second, if it has a right child, then add to queue, because that is my second next component that using which I am going to access my next diagonals head. And if it has left child, then add to answer array list, right? And using these steps, we are going to get our answer. Till what point this things are going to run? Till my size doesn't become 0, size of the main queue doesn't end, that is until I don't travel all the components. Till then I have to add the values, that is till then I have to add the components in my queue and I have to access them. So with this, I hope the video is clear to you all. Thank you for this video. Let's meet in the next video.